This is topic 6.1, special right triangles. This should be a review from geometry. Hopefully you remember it. So there's two different types of special right triangles. The first type of special right triangles is 45, 45, 90. And that refers to the angles of the right triangle. So one angle is 45, 45, and then remember that this little box in the corner means 90 degrees. So with this shortcut, you can easily find the side lengths of each triangle. So opposite of the 45-degree triangle, these is x. So the legs of your triangle are x. So these legs should be the same length. And then the hypotenuse, or the longest side, or the side across from the 90-degree angle, is going to be x square root of 2. So for these, you could just look at the side lengths and do it that way. Some of you from geometry probably use this little chart, and you can do it that way also. Okay. So find the length of the missing sides. So since this side is 24 meters, this is a leg, and I know that it's a leg because it's across from the 45-degree angle. So that means that this leg is also 24 meters. And then based on this, if the legs are x and x, that means that x square root of 2, and x is 24, so 24 times the square root of 2, that's going to be the length of the hypotenuse. Okay, so find the length of the diagonal of the sandwich, so you're looking for the hypotenuse. Example 2, it says to find the length of the missing side. And in this case, they give you the hypotenuse. I know that this is the hypotenuse because it is the side across from the 90-degree angle. So since this is the hypotenuse, that means that x square root of 2 is going to be equal to 15 square root of 2, because I know that the hypotenuse is x square root of 2. So when I look on both sides of these equations, I both have x square root of 2. I'm sorry, not x square root of 2, just square root of 2. So those can cancel out. So I'm left with x is 15. So I know that both of my legs are 15 inches. Sorry, I was having trouble writing 15. This is a 1 and a 5. Okay, so you're going to find the length of DO. Okay, example number 3, find the length of the missing side. So I'm basically looking for this A value, okay? So they give me this 19 square root of 2. This side is across from the 45-degree angle, so I know that this is a leg. Okay, and I know the leg of my right triangle is going to be equal to x. And so this is also 19 square root of 2. So I'm asked to find the hypotenuse. And the hypotenuse, or A, is x square root of 2. And I know that x is 19 square root of 2. So instead of this x, I'm just going to put 19 square root of 2. And then since that's being multiplied times the square root of 2. Well, I know the square root of 2 times the square root of 2 is the square root of 4. And I know that the square root of 4 is 2. So 19 times 2 is 38. So that means my hypotenuse is 38 units long. Since it doesn't tell me anything about my units, I'm just going to call it 38 units. Okay, so go ahead and find the length of the diagonal. This is my diagonal right here. This is also my hypotenuse. Last but not least, find the length of the missing side. So we're looking for our two legs. I know that 26 is my hypotenuse. I know it's the hypotenuse because it's across from the 90-degree angle. So I know my hypotenuse is x square root of 2. And I know the hypotenuse in this case is 26. So 26 equals x square root of 2. To get x by itself, I'm going to divide both sides by the square root of 2. So x is equal to
What is going on the mic?
26 divided by square root of 2. And then please remember that you can't leave the square root at the bottom of your fraction. So to get rid of it, I'm going to multiply the top and the bottom, the numerator and the denominator, by the square root of 2. So on top, I have 26 times the square root of 2. On the bottom, square root 2 times square root 2 is square root 4. And I know that the square root of 4 is 2. So 26 divided by 2 is 13 square root of 2. So that is my final answer. Okay, so that's the first type of special right triangle that we can have. The second type is our 30, 60, 90. So that pertains to the angles. So the angles of my right triangle are 30 degrees, 60 degrees, and 90 degrees respectively. So to find the shortcut, the shortest side or the shortest leg or across from the 30-degree angle is x. Across from the 60-degree angle is x squared root of 3. And then across from the 90-degree angle is 2x. So if we labeled that, that would be x squared root of 3, and 2x. So you can use the chart if you like, or you can just label the sides with x across from 30, 60 is x squared root of 3, and then 2x is across from the 90-degree angle. Okay, so let's use that method to find the length of BC and AC. Okay, so they give us 6, and if we look across, 6 is across from 30 degrees. So opposite of the 30-degree angle is x. So this is x. Okay, I'm going to look for BC first, so I'm looking for this side right here. And I'm just going to put a little question mark in purple there so to know that's what I'm looking for. So this side is across from the 60-degree angle. So across from the 60-degree angle is x squared root of 3. And I know that x is 6. So this is 6 square root of 3. So BC is 6 square root of 3. Okay, now I'm going to find AC. AC is going to have this blue question mark. AC is across from the 90-degree angle. Across from the 90-degree angle is 2x. X in this case is 6. So 2 times 6 is 12. So that means AC is 12. Okay, go ahead and find the length of U and V. Example 2. Find the length of AU and LA. Okay, so they give us 10 square root of 3. This is across from the 60-degree angle. So across from the 60-degree angle is x square root of 3. Okay, if you look on both sides of my equation, they both have a square root of 3. So I can cancel those out. So that tells me that x is 10. Okay, so it asks me to find AU. Here's AU. So let's put a question mark by there. AU is across from the 30-degree angle, and we know that side is also equal to x. Since x is 10, That means AU is 10. So AU is 10. LA, here's LA. Let's put a question mark. That side is across from 90. Across from the 90 is 2 times x. And we know x is 10. So 2 times 10 is 20. So LA is 20. Okay? So go ahead and find x and y for number 6. Okay? Example 3. Find the length of JA. So here's JA. Let's put a little question mark there. But let's first figure out what we have. So they give me 26. 26 is across from my 90-degree angle. So I know that 26 is equal to 2x because across from the 90 is 2x. To get x by itself, let's divide both sides by 2. And x is 13. Okay, so let's go back to my question mark. My question mark is across from, oh, wait, there's nothing there. Well, if I know this is 30, this is 90, that means this one has to be 60. Okay, JA is across from 60, so that's x square root of 3. I know that x is 13, so that means JA is x, which is 13, times the square root of 3. Okay. And then, oh, JZ, that should be AZ. Oops, let's just change that to an AZ. AZ is across from 30, and I know that AZ is x, and x is just 13. So AZ is 13. Okay, so now you're going to go ahead and find x and y. So find the length of SH and AH. Okay, so let's first look at across from 6 square root of 3, is across from 30. And we know the side that is across from 30 is my x. So that means that this is equal to x. Okay, let's find SH. Okay, SH is across from 60 degrees. And we know the side across from 60 degrees is x square root of 3. What is x? Is 6 square root of 3. So for x, let's just put 6 square root of 3. Then we're multiplying it times the square root of 3. Well, we know that the square root of 3 times the square root of 3 is the square root of 9. We know the square root of 9 is 3. So that side is 6 times 3, which is 18. So SH is 18. Okay. Now let's do AH. AH is right here. This is the side across from 90. And we know that the side across from 90 is 2 times x. So that's 2 times 6 square root of 3. So 2 times 6 is 12 square root of 3. So that is AH. Okay? So now you're going to find EW and MW.